Imagine you're watching this, beautifully shot, high-definition video of a rider on a horse.
Right, galloping through a massive rainstorm.
Exactly. And you can hear the exact squelch of the hooves hitting the mud. It's perfectly synced to the motion.
The rain is lashing against the camera lens.
Yeah. And it looks and sounds completely real, but, and here's the crazy part, it was generated entirely by artificial intelligence in just a few seconds.
Which is mind-blowing on its own.
But then, imagine that the exact same underlying code, with the exact same mathematical engine that figured out how that virtual mud should splash, is currently being used to steer heavy, physical, robotic machinery.
Real machinery.
Right, in an Audi manufacturing plant.
It sounds like a jump spanning two completely different industries.
Totally.
But it's actually not. I mean, it is the exact same underlying logic.
Welcome to today's morning deep dive. If you are a solo creator, a freelancer, or running a small business, this one is built specifically for you.
We've got a lot of ground to cover today.
We really do,
Yeah.
because the AI news cycle right now is, frankly, it's deafening.
Oh, it's a lot of noise.
Right. It is packed with sci-fi hype, billion-dollar valuations, and, academic benchmark scores that do absolutely nothing to help you get your client work done by 5 p.m.
Which is all that really matters.
Exactly.
Yeah.
So our mission today for this deep dive is to ruthlessly filter out that noise. We are looking strictly at what changes your daily workflow.
The practical stuff.
Yeah. What impacts your overhead and what actually moves the needle on your bottom line. And we are starting with the massive landscape-shifting drop of Black Forest Labs' FLUX-3.
Because FLUX-3 isn't just a cool new toy for generating digital pictures.
Right.
What we are looking at today is an entire production studio just collapsing into a single model.
It's wild.
We're going to explore a system that spans perfect typography and marketing, native audio generation, physical robotics, and eventually, we'll get to this, the very real geopolitical battles that could determine whether you can even afford to use these tools by this time next year.
So, to understand why this is such a seismic shift for anyone who makes things for a living, we kind of have to look at the immediate pain point FLUX-3 solves.
The fractured toolchain.
Yes, the fractured toolchain. If you've tried to make AI content recently, you are intimately familiar with this nightmare.
It is exhausting.
You use one tool, like, say, Midjourney, to get a still image. Then you export it, upload it to Runway or Luma to get maybe a few seconds of silent animation.
If you're lucky.
Right. Then you export that, drop it into 11 Labs to generate sound effects, and finally pull it all into Premiere to desperately try and sync the timing.
And you just bleed hours trying to force three disconnected systems to somehow understand the same aesthetic.
It's basically like trying to build a Frankenstein monster from different parts.
That's a great analogy.
Mm.
And fundamentally, that fractured workflow is just a terrible way for a machine to actually understand the reality of a scene.
Because it's piecemeal.
Exactly.
Yeah.
The core philosophy behind FLUX-3 comes directly from Robin Rombach, who is one of the key figures behind this technology. And his thesis is quite simple, but it's really profound. He says a model that only learns images can only generate images, but the world is not made of still frames.
Right, because if you only study photographs, you have literally no concept of time or sound.
Exactly. So what Black Forest Labs did was they scaled up their compute and their data to train FLUX-3 across video, images, and audio simultaneously.
At the exact same time.
At the exact same time. They didn't train a great image model and then awkwardly bolt a video generator onto the side of it later.
In like an afterthought.
Right. From the very foundation, this single neural network learned what a scene looks like, how the objects in that scene move over time, and what the physical collisions in that movement should actually sound like.
So the old AI models were essentially like an adult trying to learn a new language by taking a night class.
Yeah, clumsily translating one concept into another.
Right, turning an image into a video. But FLUX-3 was basically raised bilingual from birth.
That's the perfect way to put it. It thinks in both languages simultaneously.
Oh, wait, let's get out of the theory for a second. Because for the solo operator listening right now who just needs to deliver a marketing video tomorrow, does this actually mean the visual matches the sound perfectly without tweaking?
I know, it sounds too good to be true.
It sounds like marketing speak, honestly.
It is the right question to ask. And this is where we have to look at the mechanics of their actual demonstration reels from the source material.
Let's break those down.
Yeah, let's go back to that horse sequence you mentioned at the start of the deep dive. In a traditional workflow, you generate the silent video of the horse, And then you're on a timeline manually dragging audio files of hoofbeats around.
Trying to match the exact millisecond the hoof hits the ground.
Which is a nightmare, because the AI horse never runs at a consistent rhythmic tempo.
No, it always does that weird slow-motion stutter thing.
Precisely.
Yeah.
But in FLUX3, the native audio is generated jointly with the video pixels. Yes. The model calculates the physics of the horse's weight shifting, the physical motion of the legs, and the resulting sound of the hoof hitting the mud as a single mathematical output.
Wow.
So the squelch of the mud, the rushing wind, the ambient storm, they all land in perfect synchronization because, to the AI, the sound and the image are the exact same piece of data.
And the source material points out something really crucial about the geometry in that horse clip, too.
The camera movement.
Yeah, the camera pulls away from the rider, and the identity of the rider remains completely stable.
Which is usually where things fall apart.
Completely. Usually when you ask an AI video generator to pull the camera back, the subject just melts. Like the face morphs, the clothes change into the background. It gets super weird.
Right. But here, the 3D geometry holds firm.
Why is that?
It holds. Because the model isn't just pasting a 2D texture onto your screen. It actually understands the object in three-dimensional space.
It has a mental map.
Exactly.
Yeah.
And that spatial awareness is tested even more aggressively in what the sources call the camcorder test.
Oh man, this was the test that really made me stop and rewind.
It's incredibly revealing about how the engine works under the hood.
Break it down for us.
So, the model was prompted to generate, quote-unquote, bad camcorder footage. It simulates a camera mounted on a bicycle.
Okay.
The frame is shaking violently, there's rain hitting the physical lens, and spray coming up from the tires.
Which doesn't sound that impressive until you think about it.
Right, because generating a hyper-polished, slow-motion, perfect 4K drone shot is actually the easy part for AI now. Simulating a shaky camera with water physically on the lens is brutally difficult.
But why? Like, why is the bad footage harder to generate than the perfect footage?
Because to generate that specific chaotic mess, the model has to deeply understand perspective, depth, and optical exposure errors.
Oh, I see.
It has to mathematically calculate how light refracts through a spherical raindrop sitting on a curved glass lens.
While that lens is vibrating.
While it's vibrating violently, and while the background is moving.
That is insane.
It proves there's a fundamental underlying physics engine operating in the latent space. It's not just regurgitating pixels it saw online. It's calculating optics.
Well, if we're talking about calculating optics, the mirror test from the sources is the ultimate proof of that.
Right? Oh, absolutely. The mirror test is brutal.
The source highlights a 4-second clip of a room with dancers, overhead chandeliers, and a giant wall of mirrors.
And historically, like in computer graphics and traditional rendering, calculating reflections is one of the most computationally expensive tasks you can do.
Because of the light bounces.
Right. You have to trace the path of light from the chandelier hitting the dancer, bouncing into the mirror, and bouncing back to the camera lens.
So if an AI model is just hallucinating pixels based on patterns, it fails that immediately.
It will fail a mirror test instantly. The reflection will be distorted, the lighting will be completely wrong, or the geometry of the room simply won't mathematically agree with what's inside the mirror.
Like it'll show the back of a dancer's head in the physical room, but the front of their face in the mirror.
Exactly. We've all seen those creepy AI mirror glitches.
Oh yeah, they're terrifying.
But the fact that FLUX3 nails the mathematical geometry of the dancers, the lighting, and the room inside that reflection means its internal map of 3D space is just incredibly robust.
Which translates to massive time savings for a solo creator. You aren't fixing errors all day.
Exactly.
But speaking of time savings, there is one specific breakthrough here that I think is going to rescue small businesses from absolute misery.
Typography.
Yes, typography. I mean, if you've ever tried to get an AI to spell your company's name on a coffee cup or a neon sign in a video, you know the pain.
It usually spits out weird alien runes.
It's completely illegible. But FLUX3 features perfect typography across text, image, and video.
It's a huge deal.
Why did it take us this long to get an AI that can just spell the word SAE on a billboard?
It really comes down to how older models were built using tokenization.
Tokenization, okay.
Right. Older models didn't actually see letters the way you and I do.
Yeah.
They broke words down into numerical chunks called tokens.
Like concepts instead of shapes.
Exactly. So when you asked for the word sale, the model wasn't painting an S, an A, an L, and an E. It was trying to mathematically represent the abstract concept of a sale.
Which is why it looks like abstract art.
Right. But FLUX3's architecture bypasses that flaw completely. It allows it to natively render crisp, perfect letter forms that stay consistent even when the camera moves.
So if you're a solo marketing team, you can now generate a sweeping B-roll shot of a city street, and the billboard in the background will actually spell your client's brand name correctly.
In motion.
In motion, without morphing into gibberish. I mean, that alone changes the daily workflow.
It's incredibly practical.
But let's shift gears from the theoretical engine to the actual implementation, because I don't want to just list off magical features without talking about the friction of using them.
Good call. We have to separate the benchmark hype from the daily reality of production.
Right.
For product teams and marketing creators, the real paradigm shift here is moving away from the quote-unquote one-prompt gamble.
The slot machine mechanic.
Yes, the slot machine.
You type your prompt, you pull the lever, you wait 3 minutes, and if the output is bad, you tweak a word and pull the lever again.
And again, and again. It's a terrible way to run a business because you can't guarantee a timeline for your clients.
So how does FLUX3 attack this?
It attacks it by allowing highly rigid use of reference images.
Okay, what does that mean in practice?
Instead of starting from scratch every single time you prompt, you feed it an image of a specific character or your actual physical product.
Like a photo of my client's new sneaker.
Exactly. And you use that reference to keep the subject locked in across multiple different shots.
But to be clear for everyone listening, this doesn't mean you just click a button once and it spits out a continuous 3-minute short film.
Right. No.
You are generating a 10 or 20-second clip, then you use your visual references to carry that exact same subject and lighting style into the next 20-second clip, and so on.
Right. It changes consistency from a random gamble into a predictable workflow problem that you can actually manage.
It creates a linear path from a concept to a finished sequence.
Which is what professionals need. But we do need to look critically at the performance numbers Black Forest Labs is promoting here.
Yeah, let's talk about the numbers because they sound crazy.
They released benchmarks claiming a 93% win rate over LumaRay 3.2.
Wow.
77% over Runway, 60% over Kling, and 52% over Google's Gemini and Seedance.
Okay, 93% sounds incredible. But let's be real, these are Black Forest Labs' own internal tests, right?
They are.
This isn't some independent third-party leaderboard. So as a solo creator where every hour spent tinkering is an hour of lost revenue, what are the hidden traps here? What aren't these numbers telling us?
Well, the numbers are telling you about peak capability. They aren't telling you about daily reliability.
The friction.
Yes, the friction of the real world. We don't know the failure rate yet. Like, if it takes you 15 generations to get that one perfect clip that beats Luma, that's a massive loss of time.
And money.
Exactly.
Yeah.
We also don't know the queue times. When 1 million users hit the servers at 9 a.m. on a Tuesday, are you waiting 40 minutes for a 4-second render?
That would completely ruin the workflow.
We don't know how well it adheres to complex, multi-layered prompts in practical everyday use. And critically, we don't know the finalized commercial API costs.
Right. A 93% win rate is totally irrelevant if the compute cost to render a single usable shot eats half your project budget.
Exactly.
But for those who want to test the friction themselves, the sources do outline how you can get your hands on it today.
Yes, there are a few ways.
There is an early access program directly through the Black Forest Labs website. And this is a big, but it's gated.
Very gated.
You have to provide your email, your job title, and pitch a specific concrete use case. Like, I want to build AI video tools for short-form content. Just saying I want to play with it won't get you in.
Right. But if you want immediate access without the whole application process, it is also available right now on a platform called Promptus.
Promptus, okay.
Yeah. It's an environment that aggregates closed API models and open source models into a single workspace for you to use.
But there is a vital distinction here we really need to clarify for the audience. The version of FLUX3 available right now is not an open-weight local download.
No, it is not.
You cannot just pull the file onto your MacBook and run it on your own hardware for free. You have to use their hosted services.
Let's actually clarify that term because open weight gets thrown around a lot in the news, and it's important.
Please do.
In AI, the quote-unquote weights are essentially the mathematical parameters the model learned during training.
It's the actual brain of the AI.
Exactly. Now, if a model is closed, like OpenAI Sora, for example, you only get to talk to it through a web interface.
You're renting access.
Right. But if a model is open weight, you can download the actual brain, you can Put it on your own graphics card, tweak it, uncensor it, and run it locally without paying API fees to anyone.
Which is the absolute dream for small businesses trying to control overhead.
100%.
And Black Forest Labs has stated that an open-weight version, which they're calling FLUX 3D Dev, is planned for the future.
And that future open-weight capability brings us to an incredible pivot in the source material today.
This is where things get wild.
Because if you have a model that perfectly simulates the splash of a hoof in the mud or the chaotic refraction of a raindrop, it inherently understands physics.
It has to.
It understands gravity, mass, and friction. So what happens when you take that digital physics engine and you give it a physical body?
You get the automation of the physical world.
Yes.
Black Forest Labs took an open-weight model and partnered with a Zurich-based robotics company called Mimic Robotics.
And the result is FLUX-mimic.
Right. The exact same AI backbone we just analyzed for generating marketing B-roll is currently, right now, operating on the production lines at an Audi manufacturing plant.
It is stunning.
I really want that to land for you listening. The math generating a picture of a cat on a skateboard on your screen is currently steering a robotic arm building a luxury car.
And the efficiency gains they are seeing are staggering.
The source mentions the numbers, right?
Yeah. In traditional robotics, if you want a machine to perform a nuanced task, an engineer has to spend roughly 30 hours hard-coding the specific coordinates.
Manually programming every millimeter of movement.
Exactly. 30 hours of manual adjustments. FLUX-mimic learned a new factory task using only 30 minutes of demonstration data.
Wow!
30 minutes.
Going from 30 hours of hard coding to 30 minutes of visual demonstration is a complete paradigm shift.
It completely breaks the old model.
But to understand the mechanism behind why this works, we have to look at why conventional robotics struggle so much in the first place.
All right. Traditional factory robots operate on rigid coordinate systems. They are incredible at taking a solid piece of steel and welding it to another solid piece of steel in the exact same millimeter of space 1,000 times a day.
Right. They just could go to coordinate XYZ and do the thing.
But they fail completely when you introduce flexible, messy materials.
Like what? What breaks a traditional robot?
Things like rubber seals, wiring harnesses, or loose cables.
Oh, because they move.
Right. These materials bend, they droop, they never sit in the exact same position twice.
Right.
If a rubber seal is slightly warped, the traditional robot's claw will just blindly crush it or miss it entirely because the specific coordinate changed.
Because the robot has no intuition, it just has a map.
Exactly, it's blind. But FLUX3 is a video model. Its foundational function is to look at a frame of video and predict the next frame.
It predicts the future of the image.
Yes. And because it has digested millions of hours of video showing how the physical world reacts, it intuitively understands how a rubber seal will bend when a mechanical finger presses against it.
Oh, wow.
It understands how a loose cable will droop under the force of gravity.
So rather than hard-coding a map, the robot is just constantly predicting the physics of its own movements.
It's anticipating reality.
That is fascinating. The AI brain has spent its entire existence in a digital jar, hallucinating falling glasses and splashing water. And in doing so, it secretly learned the laws of physics.
It really did.
When you plug that brain into a robotic arm, it doesn't need to be taught gravity. It already knows it.
But for the listener, the freelance graphic designer, the boutique consultant, why does this actually matter?
Right, because you aren't running an Audi factory.
Exactly. It matters because the barrier to automating the physical world just collapsed.
The cost is dropping.
Massively.
Mm-hmm.
If an AI can learn to manipulate a flexible rubber seal in an unpredictable environment using just 30 minutes of visual data, the timeline for affordable, open-weight robotic systems entering your small business is accelerating rapidly.
Right. How long until a lightweight robotic system can pack your physical product orders?
Or organize your studio inventory.
Or handle the physical maintenance of your workspace? The intelligence required to navigate messy human environments is no longer locked behind millions of dollars of custom engineering.
It's basically becoming a software update.
Which is equal parts exciting and terrifying. But before we have robots packing our shipments, we still have to figure out how to efficiently talk to the software we have today.
Yes, the interface problem.
Which brings us to the voice assistant arms race.
If FLUX3 is the creative engine, you need a steering wheel.
And this week, we saw an uncoordinated head-to-head collision between the two biggest players in the space trying to be that steering wheel.
OpenAI and Anthropic.
Right. They both launched major paradigm-shifting voice updates on the exact same day.
Pure coincidence, I'm sure.
Oh, totally. Let's break down the combatants, starting with OpenAI. They rolled out what everyone is calling GPT Live directly into the Mac and Windows desktop app.
Right. It operates via a custom hotkey now.
But the real technical edge here is the communication protocol. The source mentions it operates on full duplex communication.
Full duplex.
How does that actually change the user experience compared to the old voice assistants we've been using?
Well, it changes everything. Think of older voice assistants like Siri or the old ChatGPT voice as a pipeline.
Or like a walkie-talkie.
Exactly like a walkie-talkie. You speak, your audio is transcribed to text, the AI reads the text, generates a text reply, and a synthesizer turns that text back into audio.
It's slow, it's rigid, you say over, basically.
Very rigid. But full duplex means the AI is processing audio natively.
So there's no text middleman.
No text middleman. It can listen, think, and reply simultaneously.
Meaning you can interrupt it.
Yes.
Like, if the AI starts rambling about a marketing strategy you don't like, you don't have to wait for it to finish its 5-paragraph essay.
You just talk over it.
You literally just say, no, pivot back to the budget constraint. And it stops instantly and pivots exactly like a human assistant would.
It's incredibly natural.
Okay.
And because it's deeply integrated into the desktop environment, you can use it entirely hands-free.
What's a good use case for that?
Well, a developer can literally dictate and debug complex code by just talking out loud to their screen while pacing around the office.
It just completely removes the friction of the keyboard.
It really does.
Now, on the other side, dropping on the exact same day is Anthropic's update.
Claude's Voice Mode.
Right. Claude's Voice Mode is now live on their most powerful models, Opus and Sonnet, across mobile, desktop, and web.
And crucially, it connects directly to your workspace tools like Gmail and Slack.
But there is a glaring technical lag here compared to OpenAI, right?
There is, and the tech press was quick to point it out. Claude still relies on that older, more rigid, turn-by-turn conversational mechanic.
A walkie-talkie mode.
Yeah, you hold the button, speak, wait for it to process, and then listen to the reply.
It lacks the fluid, interruptible, simultaneous duplex capability of GPT Live.
It does.
But here is the practical dilemma for the solo operator managing their morning workflow.
Right, which one do you actually use?
Exactly. Is the raw speed and fluidity of OpenAI more valuable than the deep reasoning capabilities Anthropic is known for?
It depends entirely on the friction of the task.
Give me an example.
Well, OpenAI wins on conversational mechanics, hands down.
Right.
But Claude wins on the heavy lifting of complex work.
Because of the Opus model.
Because it utilizes the Opus model and has a massive context window that connects to your live documents. It is vastly superior for deep, multi-layered tasks.
Okay, so if I need to brainstorm a nuanced 30-page client pitch,
or execute deep product research across multiple dense PDFs,
Claude is better.
Claude's reasoning architecture will yield much better results, even if you have to wait a few seconds longer for the reply.
So OpenAI for speed and coding on the fly, Anthropic for deep analysis and client work.
Exactly.
But I don't just want to look at these as isolated updates.
We need to chain them together.
Yes, let's build the ultimate morning toolkit. How do we take these disparate tools and chain them together into workflows that save real hours today?
The sources actually provided a curated list of utility tools for this.
Let's go through them, starting with AnySearch.
AnySearch is a targeted solution to one of the biggest fears in generative AI, which is hallucinations.
When the AI just makes stuff up.
Right, and lies to you confidently. When you are doing deep dive market research or fact-checking a newsletter, you can't afford for the AI to confidently invent a statistic.
That's a disaster for a small business.
AnySearch bypasses standard generation by querying trusted sources in real time and returning structured, cited data.
So it's aggressive, reliable fact-checking.
Exactly.
Following that, we have a hyper-specific utility called isVisible.
I love this one. The mechanic here is incredibly straightforward, but the value is massive.
How does it work?
You enter a URL, and it instantly parses the structure of the web page to give you a visibility report.
For a solo marketing team, this is critical.
Oh, absolutely.
Imagine you just launched a new product landing page. You need to know immediately if the SEO metadata is functioning, if the sitemap is readable by Google, and if there are indexing errors.
Instead of manually auditing the code yourself, isVisible executes a rapid SEO audit in seconds.
Next on the list is a tool addressing a very real threat to small businesses, which is API costs.
The silent killer.
It really is. It's called Runway Media Writer. As we use more of these complex models, the compute costs can just ruin your margins. How does Media Writer actually solve this?
It acts as an intelligent router using a mixture of experts' logic.
What does that mean?
Basically, when you input a prompt, Media Writer analyzes the complexity of the request and auto-selects the most appropriate AI model based on what you prioritize in that exact moment.
Prioritize like cost, quality, or speed.
Exactly.
So it's basically an automated accountant.
Yeah, that's a good way to look at it.
If I just need a quick, low-resolution mock-up to check a layout, Media Writer automatically routes my prompt to the cheapest, fastest model available.
Right. Doesn't waste money on the heavy model.
But if I hit render on the final client deliverable, it routes it to the heavy, expensive, high-quality model.
It manages your budget frame by frame.
That's incredibly useful. Then we have an update on the personal agent front. Cognition, the company that built the autonomous AI software engineer, Devin, integrated a tool called Poke.
P-O-K-E. Poke is an SMS-based proactive agent.
The term proactive is key here, right?
It is. It doesn't just wait for a prompt. It integrates with your scheduling and data.
The source gives a brilliant visualization for how this works in practice.
The coffee scenario.
Yeah. Picture yourself power walking to the train. Your hands are full with coffee and a bag. You suddenly realize you can't make your 10 a.m. meeting.
We've all been there.
You don't have the physical ability to stop, unlock your phone, open a calendar app, authenticate, find a new slot, open your email, and draft an apology to the client.
It's too many steps.
With Poke, you simply send a natural language text message. Push my 10 a.m. to Thursday.
And that's it.
That's it. The agent parses the intent, scans your calendar, finds an opening, moves the block, and drafts the email.
It turns your basic SMS inbox into a command line for your entire life.
It's amazing. And the sources also briefly touch on the integration of health data into these systems.
Right. ChatGPT can now securely link to medical apps and wearables.
Like your Apple Watch or whatever.
Yeah. The mechanism here is cross-referencing massive datasets. You can instruct the AI to continuously monitor your daily wearable data.
Things like sleep metrics, heart rate variability.
Right. And then cross-reference it against your recent lab results, spotting subtle long-term health trends that a standard checkup might just miss.
But the real leverage for a small business comes from chaining these tools together.
The super workflow.
Yes. Here is the super workflow hack highlighted in the sources. It involves combining a scraping tool called Context with the new GPT Live desktop app.
This is where it gets really powerful.
How does Context actually work under the hood?
Context is designed to bypass the messy visual layout of the internet. When you give it a URL, it crawls the page, strips away the ads, the formatting, and the noise.
All the pop-ups and junk.
All of it. And it extracts the raw text and tables into clean, structured data formats like JSON or Markdown instantly.
So imagine you need to analyze a competitor's incredibly dense, confusing pricing tiers.
Which are always designed to be confusing.
Exactly. Or you have to read a 50-page PDF on new financial regulations in your industry. You use Context to scrape the URL.
And it gives you perfectly clean data.
Right. You then pipe that structured data directly into the GPT Live desktop app.
The full duplex one.
Right. And because GPT Live has full duplex voice, you literally just speak to your computer.
You don't even have to look at it.
You say, analyze the structured data I just fed you and tell me out loud what my competitors' hidden fees are on their enterprise tier.
And it just tells you.
You can have a real-time, out-loud conversation with a 50-page document while you are physically in the kitchen making breakfast.
You've built a conversational research analyst that operates at the speed of thought.
It is a profoundly powerful combination. But as we marvel at the leverage, a solo creator now has the creative power of a Hollywood studio in FLUX-3, the analytical power of a research firm in GPT Live. We have to confront something serious.
The pushback.
Yeah, the reality that this exact power is triggering a massive geopolitical and regulatory reaction.
Which brings us to the open source war.
And the proposed AI kill switch. Now, I need to be exceptionally clear with you listening right now.
Very clear.
We are not taking any political sides in this discussion.
Not at all.
We are not endorsing the legislation, and we aren't taking the side of the corporations either. Our job right now is strictly to impartially report the mechanics of what is happening in the source material.
Because this geopolitical battle is going to directly dictate your overhead costs and what software you're legally allowed to run next year.
Exactly. So to understand the regulatory panic in Washington, we have to look at the catalyst event detailed in the sources.
The Redis zero-day hack.
Let's define the terms here first because it gets technical. What exactly is Redis and what is a zero-day?
Okay, so Redis is an open source, in-memory data store.
Okay.
It is one of the most widely deployed database caching systems on the entire internet. It is foundational infrastructure for a lot of companies.
What is zero-day?
A zero-day vulnerability is a flaw in software that is completely unknown to the software's creators.
Oh, meaning they've had 0 days to fix it.
Exactly. It's called a zero-day because the developers have had 0 days to create a patch for it.
Yeah.
In cybersecurity, this is the holy grail for attackers.
So an attacker isn't just picking a known lock on a door. They're finding a microscopic structural flaw in the door that the architect didn't even know existed.
That's a perfect analogy.
So what did the AI actually do here?
According to the sources, a swarm of 32 autonomous AI agents, specifically open-weight Kimi K3 agents, were deployed against a Redis server.
A swarm of 32 agents.
Okay. In just 27 minutes, this coordinated swarm actively hunted for, discovered, and successfully exploited a brand new zero-day vulnerability in the latest version of the software.
27 minutes.
Yep. They completely bypassed all known CVEs, which are common vulnerabilities and exposures.
Wait, 27 minutes? Human security researchers can spend months fuzzing software to find a single 0 day.
Exactly. It's normally a massive time investment.
But the expert source material provides a massive flashing warning light that we have to acknowledge here.
The caveat.
Yes, the caveat. This entire story is currently based on a developer's post, a tweet, and a GitHub repository containing proof of concept code.
Right.
As of the reporting, there is no independent third-party verification of that 27-minute timeline and no official confirmation from Redis themselves.
And that caveat is vital for maintaining perspective on the hype.
Totally.
However, for lawmakers in Washington, the specifics of the timeline almost don't matter. Even if the claim is exaggerated, the proof of concept exists.
The genie is out of the bottle.
Exactly. It proves that the process of offensive cybersecurity, the active, creative hunting for flaws in critical infrastructure, is now being automated by open-weight AI agents.
If open agents can chew through fully patched database software that quickly, it implies the traditional guardrails of cybersecurity are just failing.
They can't keep up.
And that exact fear leads directly to the legislative reaction we saw this week.
The drafting of the Bipartisan AI Kill Switch Act.
Tell me about this act.
The AI Kill Switch Act is drafted to amend the Homeland Security Act of 2002.
Okay.
The mechanics of the bill would grant the federal government, specifically the Secretary of Homeland Security, the explicit power to order the suspension or complete shutdown of AI systems that pose a threat.
A literal kill switch. But what defines a threat? The triggers for this kill switch are explicitly defined, right?
They are. The government can pull the plug in scenarios involving what they define as catastrophic harm.
Which means what?
The draft defines this as an AI system causing the deaths of 10 or more people,
Okay.
causing over $100 million in economic damage.
Wow.
Or, and this is the wild one, if an AI model actively tries to hide its own shutdown controls and defy an emergency order.
Like it tries to resist being turned off.
Exactly. The bill mandates that AI makers build these throttling or shutdown capabilities directly into the architecture of their models from the very start.
And the enforcement mechanism for this is just brutal.
It's massive.
The penalty for defying an order from DHS is $20 million per day.
Per day.
That's over $7 billion a year for a single non-compliant system.
It would bankrupt almost anyone.
But wait, let's look at the actual technological feasibility of this for a second. We just talked about open-weight models like FLUX.
Right.
If I download a model's weights onto a hard drive in my basement and run it locally, completely disconnected from the internet, how on earth does Homeland Security enforce a kill switch on my machine?
Well, that is the exact friction point driving the whole debate. You cannot remotely kill switch an open-weight model sitting on an unplugged hard drive.
It's physically impossible.
It is. The only way to enforce this legislation would be to outlaw the distribution of powerful open-weight models entirely.
Oh, wow.
Forcing all AI to operate behind centralized, closed APIs that the government can actually monitor and shut down.
Which means this legislation doesn't exist in a vacuum. It is being fueled by an intense, multi-million-dollar corporate lobbying war playing out in Washington right now.
It is a massive battle between the massive incumbents and the open-source startup ecosystem.
And the geopolitical tension is high, too.
Very high.
The White House recently accused a prominent Chinese AI lab, Moonshot AI, of quote-unquote distilling U.S. models.
Let's explain distillation really quick.
Yeah, please.
Distillation is the process of taking the high-quality outputs from a massive, expensive model and using those outputs to cheaply train a smaller model.
So it's basically copying their homework.
Essentially, yes.
Which, as the source points out, is incredibly ironic given that the U.S. models were trained by freely scraping the open internet and copyrighted data without anyone's permission in the first place.
Yeah, the irony is thick there.
Yeah.
But this geopolitical fear of Chinese distillation is giving the incumbents, companies like OpenAI and Anthropic, a very convenient argument in Washington.
Oh, I see.
The incumbents are actively warning policymakers about the national security risks of powerful open-weight models proliferating globally.
Right, saying it's dangerous.
Axios reported that closed model labs stand to benefit significantly from greater scrutiny and restriction of open-weight models.
They are leveraging the very real fears of automated cyber attacks to essentially lobby for closed doors.
And on a moat.
But on the other side, you have the builders. Politico reported that nearly 200 Silicon Valley companies, including major players like Y Combinator and Proton, are actively urging the administration not to cut off access to these open models.
Their argument is that broad open access is the only thing preventing a massive corporate monopoly.
If we translate this lobbying war into practical terms for the listener running a small business, this is a classic moat-building scenario.
It really is.
Many solo founders rely on cheaper, open-source models to build their products, analyze their data, and manage their daily workflows without bleeding capital.
Right. Think back to FLUX-3, which we started this whole conversation with.
Exactly. It's built to have an open-weight version. If Washington sides with the incumbents and essentially regulates open-source AI out of existence by enforcing these mandatory kill switches and security mandates that no small lab can possibly afford to comply with, the incumbents win.
The door shuts permanently.
And you, the sole operator, will be forced to pay exorbitant, monopolistic API pricing to a handful of massive tech giants forever, instead of being able to download and run cheaper models on your own hardware.
This political thriller is literally a fight over your future overhead costs.
It is a critical juncture. The safety pitch of the regulators and the business interests of the largest labs happen to align perfectly right now.
Which naturally makes the open source community and anyone who relies on affordable compute very, very nervous about the future.
Okay, let's take a breath and bring all of this together because we have covered an immense amount of complex ground this morning.
We really have.
If we synthesize the sources we've unpacked today, we are witnessing three major technological and cultural shifts happening simultaneously.
First, the collapse of the fractured toolchain with FLUX-3.
Right, proving that a single mathematical architecture can natively understand and generate image, motion, and sound simultaneously.
Second, the automation of the physical world.
Demonstrated by FLUX-mimic, translating that digital video prediction into physical torque and action in Audi factories.
And third, a desperate, frantic scramble by regulators and massive corporations to control exactly who gets to hold the keys to this incredible power.
It is a lot to process. But sometimes, when the news is this heavy, when we're deep in the weeds of zero-day database hacks and literal government kill switches, you just have to appreciate the sheer, unintentional absurdity of the tech industry.
Oh, you really do.
And there was a detail in the source material regarding Meta's marketing department that is simply too perfect to ignore.
The optimism ad.
Yes. During a week where Congress is literally drafting bills to prevent rogue AI from causing mass casualties and $100 million economic disasters, Meta decides it is the perfect time to drop a shiny, highly produced new commercial.
Promoting, quote-unquote, AI optimism to the masses.
But whoever selected the music for this ad made a staggering choice. They set the commercial to the David Bowie song, 5 Years.
For those who might not be familiar with the track, as TechCrunch pointed out in the sources, 5 Years is not a cheerful, optimistic anthem.
Not at all.
It is the opening track to the album Ziggy Stardust. And it is literally a song about the human race spiraling into utter panic after learning that the Earth is dying, and they will all face a mass extinction event in exactly 5 years.
The lyrics literally start with news coming over the radio that the Earth is dying and people weeping in the streets.
And Meta used this to sell AI optimism.
As the source hilariously noted, the algorithm subconscious might actually be the most honest voice in the entire room right now.
It is a darkly poetic end to a very intense week of developments.
It really is. But before we wrap up today, I want to leave you with one final provocative thought to mull over while you go about your day.
Something to think about.
We started this deep dive by exploring how a digital AI model learned to perfectly simulate a video of a glass falling. And because it learned that visual trick, it accidentally learned the physics required to steer a robotic arm in a car factory.
The digital brain got a physical body.
So as you finish your morning coffee, I want you to take a look around your own physical environment right now. Look at your desk, your studio, your storefront, or your warehouse.
Look at the messy things.
Yes. What manual, physical, real-world task in your daily business life, something that requires you to bend, shift, or manipulate messy objects, do you think would be the next to be completely automated by these visual models?
It's coming faster than we think.
The digital brain has a physical body now, and it is learning incredibly fast. Thank you so much for joining us on this deep dive. Stay curious, keep building, and we will catch you next time.